all to our first experiment online. This is experiment 3. A couple of announcements. Wednesday, 25th, that's when the post lab for experiment 2 is due. You do need to do the pre-lab and data observations for experiment 3 on Wednesday. And then, of course, the post lab is due later, and this accounts for spring break, so it's due much later after you work on the experiment. And remember, all times are at the end of the day, 11:59 p.m. Several people are tuning in to office hours, but still got plenty of room, so come check it out. Office hours around Monday, Wednesday at 12:30 using Zoom. And I'll send you either an invitation or you can enter through Canvas. And I'm still working on exam 1 grades. So today, and actually when I teach this in lab, I really emphasize the concepts that are going to be taken away from this experiment, with really trying to, reassure you do not have to understand the complexity of nanoparticle chemistry. That is not the goal of this experiment. The goal is to see a few things. The theme of the textbook, structure determines properties. You'll see that right away in this experiment. Green synthesis, I'll talk a little bit about that. And then if we're talking about structure determines properties, we're going to use absorbance, what you saw on activity 7. And you can also just see the nanoparticles. There's color to the nanoparticles, but we're going to use that absorbance, that wavelength, to then determine the size. So that's this whole structure determines properties. And as I've already said on previous video, experiment 3 is on Wednesday, and then spring break. All right, so goals. What do I really want you to get out of this? As I've already mentioned, to see this relationship, structure determines properties. The whole goal is to estimate structure. That's the size. What's the size of the nanoparticles that are created? And you get that from the SpectraVis Plus. That gets you the color, or specifically that gets you the wavelength or the lambda max that I'll talk about. So that's the first goal. See this theme come true. The next, we're going to use a technique called green synthesis, which means it's environmentally friendly. You don't use a large amount of products. You don't use harsh reactants. So it's something that you can really do in an efficient way. It works, and it's not harmful to the environment. You've already seen that activity introduce you to SpectraVis Plus. This would continue to gain understanding using the SpectraVis Plus. But you can see all of this is saying that's the goal. The goal is not what is a nanoparticle, can you define a nanoparticle, can you give examples of how the technology works. Like, these are all things that are background, that are information, but these are the real goals that I'm mentioning here. You do need this definition that's key, lambda max. So the highest absorbance, we're looking at the wavelength of this. So we saw this in activity 7. If you have absorbance versus wavelength, you're going to have some peak, and the lambda max would be that highest point. Okay, so that's what we're looking for. And in this case, for the nanoparticles, it needs to be between 500 and 600 nanometers, because some of the nanoparticles actually have 2 peaks. So we're going to look in a specific range. We're going to look for the max in that range. And then the real key here, we have to have an absorbance less than 1. So from the activity you saw, if you diluted it, the curve should look the same, which these don't exactly look the same, but you can get the absorbance down to less than 1. So those are the things I'll take into account for the lambda max. Okay, so if you are performing this in lab, here's the reality. There's a lot of techniques in here. The gravity filter, you do that with filter paper, but you have to fold up the paper. You have to make sure the paper is adhered to the funnel, put some water on it, make it seal really nicely. This is the only class out of Chem 152, 200, and 201 that uses micropipettes. So it uses micropipette at a very small volume. Graduated pipettes are an important use, so you get to estimate by looking at the lines. Am I using 2 mils? Am I using 3 mils? Am I using 4 mils? So a graduated pipette, you can choose the volume that you use. It's also kind of fun. You get to use magnetic stirrers, so that's the hot plate, but you turn on the magnet side, and the stir bar that you use in experiment 1 as your magnet will spin around and swirl the solution. That's nice. Volumetric flasks, that is glassware that's really important, but it's not easy to use because it only has one line. Okay, so that's volumetric flasks that you'd use in this experiment. You'd do 2 trials. The first one would be the stock solution, and you'd use some tea. So again, really natural products, green synthesis, and then you'd use water. This HPLC is just saying this is very purified water. HPLC is an instrument that's used in high-level chemistry, so it requires really high quality water. The second solution, you're going to use more of the tea, but you're diluting the tea. You're only using 6 to 10% of the tea solution. So you take 3 to 5 mils of the tea solution, you dilute it, and then you make more nanoparticles, and sometimes it can really take 40-50 minutes to make the nanoparticles for the second batch. Other things you're going to do, if you would do this in lab, you'd have to be able to recognize the absorbance needs to be less than 1, so you have to keep track of dilution. The first stock solution is usually very strong, so you might get absorbances 1.78, really high. So I recommend then diluting with a 1 to 20 ratio. And what that means is you take 1 mil of the nanoparticle, that's what you made, and then you take 19 mils of HPLC water, that's a 1 to 20 dilution. And you recall that that all comes from activity 7, this M1, V1, M2, V2 equation. So if this was quantitative, you could solve for it. But that leads us to the next point. This is very qualitative. This experiment 3, you want to know that absorbance is proportional to concentration. We're not finding the specific concentration. Guess what? You're just estimating the size. Okay, this is not what is the size specifically. Is it 30.4 nanometers? No, we're just estimating based on our absorbance. The quantitative piece, though, we've already talked about. Making dilutions, you would need to know, is it 1 to 20? Is it 1 to 10? Volumetric flasks, you would need to use the glassware correctly and go to the mark. Same with the pipettes. Okay, if you're using graduated pipettes, then you need to make sure you're using the right volume, like 2 mils. If you're using the micropipette, you need to make sure to know how and learn how to use that properly and to transfer the volume. So all these things would be what you're developing if, that's the big if, right? If this was going on in lab. All right, so a couple of background notes. So again, some of this is in the experiment, but I just wanted to point out again, what you're working with is tea leaves, and you're making a tea leaf solution, and this is probably the hardest part to miss out on. That's a gold solution that you're adding to it. Okay, so you're adding this gold acid solution, and then in not too long of a time, you get nanoparticles. So you get this deep color that tells us right away something different has happened. Okay, so this is a color change indicating this is a nanoparticle. So what are nanoparticles? I already mentioned this a little bit. They're small, they're nanometers. You can see they have a lot of interest. Okay, so in your background as you write the pre-lab, maybe you want to look at this and say, what does it mean to use nanoparticles in medicine, electronics, or energy? So that's something you can look up. Again, this is not the core focus, how is nanoparticles used in medicine, but to see that nanoparticles have lots of applications is really interesting. And the reason is because of the differences. Nanoparticles are different than bulk samples. So the table that you saw to start, you can see here pointing out some of the significant differences. One thing I just want to point out is distinct. This is very qualitative terminology, metal, semi-metal, but clearly there's a difference in these substances. Bulk gold, not reactive, inert. Gold nanoparticles, they can act as a catalyst. So this is definitely pointing out the differences with nanoparticles. So the takeaway then, what you're going to see is the data will be presented with absorbance versus wavelength. And remember, we're looking for lambda maxes. So if I estimate here, that's a lambda max, that's a lambda max, that's a lambda max. So different T solutions, 10%, 5%, 1%, those different solutions give different lambda maxes. And remember, one of the goals of this experiment is to use the lambda max to estimate the size. So you'll have a table, it shows the size of the nanoparticles. So you can see then this wavelength down here, you can estimate the size, and down here, estimate the size. So make sure you check out videos on making nanoparticles. Data is provided, then you need to look at your pre-lab, complete the pre-lab. You need to rewrite the data observations, make that as your own, and then again, post-lab would be due after spring break.